Have you ever looked up at the night sky and wondered what secrets it holds? Maybe you've even heard whispers of an ancient alien visitor lurking in Earth's orbit. The Black Knight satellite. But is it a genuine extraterrestrial artifact, or something a little closer to home? We're about to blast off on a mission to separate fact from fiction. Buckle up, space cadets, because we're diving deep into the mystery of the Black Knight. The night sky, a tapestry of cosmic wonders, has long been a source of human intrigue and mystery. Among the myriad celestial phenomena, the Dark Knight satellite story stands as a particularly enigmatic chapter in the annals of space lore. Legend tells of an object lurking in Earth's orbit, whose origins and purpose are shrouded in secrecy and speculation. The saga began in the early 1950s, when media reports emerged about an unidentified orbiting object detected by radar. This was years before either the United States or Soviet Union had the capability to launch such a satellite. The mystery deepened with the revelation that famed inventor Nikola Tesla had received potentially extraterrestrial radio signals in the late 1800s, which some believe could be linked to this shadowy satellite. The name Dark Knight itself conjures images of a silent guardian, an observer in the darkness of space. This moniker, though unofficial, encapsulates the essence of the mystery that continues to captivate conspiracy theorists and skeptics alike. As we delve deeper into the origins and implications of this cosmic conundrum, the line between science and science fiction blurs, challenging our understanding of what lurks beyond the earthly bounds.
The realm of space exploration is rife with unexplained phenomena that often lead to theories of extraterrestrial artifacts and communications. The Dark Knight satellite is frequently cited as a prime example of potential alien technology surveilling our planet. This theory is bolstered by accounts of unusual signal receptions, notably those detected by Tesla, and later by radio enthusiasts during the Cold War era. These signals, often described as inexplicably sophisticated and timed, suggest an origin that is not only intelligent, but possibly far beyond our current technological capabilities. The intrigue is magnified by the U.S. government's historical penchant for secrecy regarding unidentified aerial phenomena, which provides fertile ground for speculation about hidden alien liaisons or surveillance mechanisms. Furthermore, the aspect of alien communication ties into broader conspiracy theories that involve governments using space-based devices for global surveillance or even control. The persistent allure of these theories speaks to our deep-seated curiosity and fear about the unknown entities that could be watching us from the dark recesses of space. It challenges our understanding of sovereignty and the potential for interactions that could alter the course of human history.
In 1998, the Space Shuttle Endeavour mission STS-88 became a cornerstone of Dark Knight lore, when astronauts photographed what appeared to be an unusual object in orbit. Initially dismissed as a stray piece of space debris, specifically a thermal blanket, the images fueled rampant speculation about its true nature. The object's peculiar structure and reflective properties led some to assert it was of extraterrestrial origin. The debate over the thermal blanket explanation highlights a broader issue in space exploration: the identification and tracking of objects in orbit. NASA's official stance that the photographed object was mundane debris does not satisfy those who point to inconsistencies in the object's appearance and behavior when compared to known space junk profiles. Supporters of the alien artifact theory argue that the object's trajectory and stability in orbit suggest a controlled or designed mechanism rather than a random piece of insulation. This incident serves as a prime example of how space missions can unintentionally become focal points for conspiracy theories, feeding into larger narratives about extraterrestrial monitoring and engagement with Earth.
As humanity's orbital endeavors have expanded, so too has the cloud of debris encircling our planet. From spent rocket stages to defunct satellites, this floating detritus poses a significant risk to spacecraft and stations currently in orbit. The velocity of these objects, often exceeding several kilometers per second, can turn even the smallest fragment into a lethal projectile. The issue of space debris is exacerbated by collisions and the resulting fragmentation, which in turn generates more debris in a cascade effect known as the Kessler syndrome. This scenario, where the density of objects in low Earth orbit is high enough to sustain a chain of collisions, could render space activities and satellite operations unsustainable for generations. Efforts to map and track these objects are crucial for mitigating collision risks, but the current tracking systems can only monitor a fraction of the debris that exists. The limitations of our current technology to effectively manage this growing cloud of orbital refuse presents a formidable challenge to both current and future space missions.
Addressing the escalating problem of space debris requires innovative solutions and international cooperation. One promising technology is the use of lasers to nudge debris into deorbit trajectories, effectively clearing paths in busy orbital lanes. Another approach involves deploying specially designed spacecraft to capture and remove large pieces of junk, either by bringing them back to Earth or sending them into a disposal orbit. These technological solutions, however, are just one part of the equation. Effective space debris management also hinges on robust policy frameworks that mandate debris mitigation strategies during the planning stages of space missions. Such policies would require the deorbiting of satellites at the end of their operational life or the design of spacecraft that minimize debris creation. Moreover, as commercial space ventures become more prevalent, it is imperative that industry stakeholders adhere to international guidelines designed to minimize orbital debris. The sustainable exploration of space depends not only on technological advancements, but also on a collective commitment to preserving the orbital environment for future generations. The mysteries and challenges of space debris encapsulate the dual nature of humanity's reach into the cosmos, our greatest technological achievements shadowed by the debris of our endeavors. The Dark Knight satellite, whether a myth or misunderstood piece of space history, serves as a metaphor for this broader issue. It compels us to look critically at the impact of our actions on the space environment. As we move forward, the sustainability of space activities will increasingly depend on our ability to manage and mitigate the remnants of our explorations. This requires not only technological innovation but a global perspective that transcends national interests. The path we choose will determine the legacy we leave in the vast expanse of space. It is through the lens of challenges like these that we can truly appreciate the complexity and interconnectedness of our technological pursuits and their repercussions. The enduring enigma of the Dark Knight and the tangible issue of space debris both remind us of our responsibility to steward the cosmos as thoughtfully as we navigate our own planet. Thanks for joining SciSips on this cosmic journey. Let us know in the comments below what other space mysteries you'd like to explore. Don't forget to like this video and subscribe to SciSips for more out-of-this-world content.